こんにちは。シリコンラボラトリーズの高山です。シリコンラボラトリーズ本社はアメリカのテキサス州オースティンにありまして、アメリカ、ヨーロッパ、中国などで開発拠点を持つ半導体ベンダーになります。で、IoT に特化した無線 SoC、マイコン、センサー、プロトコルスタックなどを提供させていただいております。本日はですね、インダストリアル&コマーシャル IoT ビジネスユニットのダイレクターであるアビヒジット・グレワルの方からスマートシティドライビングサステナビリティゴールズというようなタイトルで講演させていただきます。こちらの方、ビデオでの講演となります。この講演の中でですね、はじめに国連の方で掲げる SDGs の目標に非常に大きく貢献するスマートシティ、電力、水道、ガスメーターのインフラストラクチャーを含めたスマートシティについて説明します。で、その後にですね、スマートシティの実現、あるいはスマートシティの進化に対して非常に大きく貢献するキーのテクノロジーとなるべき Y さんについて触れたいと説明させていただきたいと思います。で、最後に弊社の製品の紹介とさせていただきたいと思います。はい、それではビデオの方を流させていただきます。
高山さん、今、ビデオの方は見えてましたけども、音がちょっとだけ聞こえただけで。
We're very passionate about.
大丈夫です。
Hi, I'm Abhijit Grewal, Director of Marketing in the Industrial and Commercial IoT Business Unit at Silicon Labs, and I run the Smart Cities business segment. We're very passionate about what we're doing in the Smart Cities team. Silicon Labs' wireless portfolio is at the core of products and solutions which are making a major impact to the UN sustainability goals. We're working with industry leaders who are building the next generation advanced metering infrastructure networks for both electric and water utilities, smart water solutions for flow and leak detection. Our wireless solutions are being used today in both residential as well as commercial solar. We are in electric vehicle supply equipment, and we're also enabling utilities to bring microgrids into their traditional grid infrastructure. And the list of applications goes on and on. As you can see, the applications we're driving within smart cities tie into the UN sustainability goals highlighted on this slide. We see ourselves as an enabler. So what do I mean by that? Silicon Labs' wireless portfolio is enabling our customers to build products which is helping create a better world, both for the present as well as future generations, and is something we're extremely proud of and also gives us a North Star vision to execute on. So what are some of the segments we're targeting in the smart city ecosystem? Utility monitoring and control, which includes electric, water, gas meters, and the distribution networks behind them. Municipal infrastructure, which includes street lighting, traffic lights, weather stations, environmental sensors, and parking. And last but not the least, energy production, which includes microgrids, renewables, including residential and commercial solar and solar farms, electric vehicle supply equipment, which includes car battery chargers, as well as the charging infrastructure. So what are some of the technologies which are prevalent in this space? Within smart cities, we deal with a lot of customer proprietary networks. In some of the applications, we're also starting to see a trend moving towards standards-based networks like Wi-Fi, U-Bus Air, WM-Bus, and Zigbee. And last but not the least, wide area networks based on cellular IoT or LoRa, which can be both public as well as private. In addition, we're starting to see customers use BLE and Wi-Fi for commissioning and debugging end nodes, which are connected via one of the long-range networks. This slide shows how the grid infrastructure is evolving. The state of the art today is AMI, where the meters are wired or wirelessly connected to a central control station, which gives the utility real-time access to energy consumption data. Adding renewables like solar and wind to the mix, which includes both residential solar as well as solar and wind farms, adds complexity to the utility infrastructure. Since energy flows from the traditional grid to the end nodes, as well as from the distributed energy sources like solar and wind back into the grid. Now that energy generation infrastructure is set up, the utility has visibility into real-time energy consumption so that they can automate the entire distribution process, which allows them to distribute the energy more efficiently. One of the very interesting applications here is pole tilt sensors on distribution poles and streetlights to primarily pinpoint the exact location in case any of the poles are damaged because of hurricanes, strong winds, and other calamities. Adding intelligent street lighting to this AMI network, which in addition to automating the streetlights, also enables municipal infrastructure applications like environmental sensors, weather stations, manhole detectors, waste management, etc. Since the street lighting canopy can act as a gateway for all the sensors. This changing utility landscape has opened up a huge SAM for IoT. If you talk to the utilities and the tier 1 metering vendors, everyone is talking about distribution automation, which is automating the electric distribution network and edge intelligence. So why is that? If you take a look at the traditional grid, energy flows from the grid to our homes, so it was always a one-way street. With renewables, especially solar in homes, that model has now changed. Nowadays, energy flows from the grid to homes and also flows from the homes back into the grid. So it's no longer a one-way street. Someone has to manage or control this energy flow, else you can easily destabilize the grid. Since real-time decisions have to be made about routing energy so that the entire infrastructure can run efficiently, latency needs to be minimized and end nodes need to become more intelligent, which implies that the overall throughput has to substantially increase. Gone are the days when the electric meters were operating at tens of kilobits per second. This changing landscape is driving towards throughput of hundreds of kilobits and even single-digit megabits per second. Silicon Labs is the market leader in wireless metering and the #1 wireless supplier in this space. We have the most comprehensive wireless hardware and technology portfolio available and are in production and also closely working with customers on new designs across all tiers in the Americas, Europe, and APAC, including Japan. Water is a highly critical and valuable resource, and there is a significant amount of water, as much as 40%, which gets lost because of leaks and thieving, which causes a huge strain on the utility industry. Leaks are a huge strain on the water distribution network because in addition to losing water, now in order to maintain the same amount of water pressure, one has to run the pumps at a much higher power, hence consuming substantially more electricity. In Austin alone last year, more than 6 billion gallons of drinking water was lost because of leaky pipes. That's not a small amount by any means. So how does automation help alleviate this issue? Firstly, making the water meter smart so that you can have access to real-time water consumption data so that customers can make educated decisions around their water consumption needs, and also helps determining whether one has faulty or leaky faucets or pipes in their homes. Now, if you start adding flow sensors to the water distribution infrastructure, one gets complete visibility into the entire ecosystem, which now makes it very easy to determine leaks in the distribution network, and hence opens up significant opportunities outside of metering also. Moving on to the next slide, the gas distribution network works very similar to the water network, and the problem statement is also very similar. Getting the meter readings, determining leaks, and fixing them before they become life-threatening. The flow measurement techniques for water and gas are also very similar. Reason you see the same companies building solutions for both water as well as gas infrastructure. In the previous slides, we have talked about distributed energy resources and how they're helping advance their utility infrastructure. If you look at a generic solar installation, it includes PV modules, string inverters with optimizers, microinverters, and a gateway to enable seamless, reliable, and secure remote control and monitoring of the solar installation. Now, for this use case, what benefits does wireless connectivity bring to the system? Wireless connectivity, first of all, removes the need for additional PLC cabling, reducing weight and installation and maintenance costs. Wireless mesh networking offers unlimited scalability, allowing system integrators to easily customize your system for sites of all sizes, from small residential homes to large enterprise and industrial installations. As you can see, there's a substantial number of benefits which wireless connectivity brings to the table versus a wired solution. This slide shows how connected or intelligent street lighting enables efficient use of street lights which drive energy conservation. There are times when you drive in the mornings, you still see the street lights on in bright sunlight, which is absolutely a no-no from energy conservation standpoint. Automation prevents this from happening. Automation allows remote control of streetlights, which improves longevity of the bulbs and hence reduces the maintenance costs. In addition to that, intelligent streetlights, it's extremely easy to pinpoint the location of the fault versus driving around in the neighborhood to find the faulty streetlights needing repair. The intelligent street lighting is a huge market opportunity. All the regions are highly untapped based on the existing coverage, with huge growth expected over the next few years. We currently have customers who are doing sub-gigahertz proprietary protocols, standards-based solutions like Wi-Fi, Zigbee, and others for intelligent street lighting solutions. Because the street light canopy is higher above the ground, it provides increased network coverage and resiliency. As a result, it's a perfect spot to act as a gateway for smart city applications like air quality sensors, methane gas detectors, and citywide infrastructure applications like waste management, weather stations, traffic lights, parking, as well as asset tracking. Now let's talk about WISEN. What is WISEN? The WISEN Alliance's mission is to drive the global adoption of secure interoperable wireless solutions for use in smart cities, smart utility networks, and other IoT applications using open global standards supported by a rigorous testing and certification program. Silicon Labs joined the WISEN board in 2020. As you can see, the WISEN board of directors comprises of leaders in the smart city infrastructure space. This is a lot about a technology if you have the leaders backing and supporting it. There are close to 100 million and counting WISEN capable endpoints deployed worldwide. We strongly believe that WISEN is the most complete IoT standard for smart city and industrial use cases, since in addition to being a self-forming and a self-healing mesh, it supports high throughput use cases like edge intelligence with electric meters and street lighting, and also has support for long-range applications like battery-powered meters and environmental sensors, all on a single network, thereby unlocking massive IoT smart city applications. Smart cities is a highly fragmented ecosystem, which includes both star and mesh-based technologies, primarily driven by customer application needs. Silicon Labs has a high-performance, low-power, and cost-competitive SoC portfolio, and we're continuing to invest in the hardware roadmap. As you can see, the technologies driving smart cities are highly fragmented, which means that in order to succeed, we need a highly configurable radio, which supports both proprietary and standards-based technologies, and we support all that. We have the industry-leading security with our Series 2 portfolio. As you're all aware, security requirements are increasing in the utility space, and secure key storage and secure identity are starting to become a must-have for future platforms. Silicon Labs has a FAN 1.0 certified stack running on Series 1 platform. And we also have a FAN 1.0 certified border router reference design. I would also like to mention Nagano JRC here, who have built a sub-gigahertz mesh system-level solution with a Series 1 product portfolio, which in turn would help expedite the time to market to make time to market significantly for potential customers. There's a huge opportunity across all different smart city segments in front of us, and Silicon Labs is in a very solid position to become a dominant supplier in this space. Thank you very much.
ありがとうございます。どうぞ。
はい、最後にですね、弊社のジャパンオフィスのコンタクト先だけ表示させていただきたいと思います。弊社、アメリカが本社になりますけれども、日本でも支社を持っております。で、こちらの方で深田が日本代表として働かせていただいております。で、私、高山の方が FAE として働かせていただいております。ぜひこちらのメールアドレスの方にコンタクトいただければありがたいです。それでは本日はありがとうございました。